Hi everyone. In the last session, we have discussed the concept of the recursion. And I said that the process of calling a function by itself is called the recursion. And also we discussed the difference between the iteration and the recursion. And also I said that the best examples for finding or the best example for the recursion is finding the factorial of a given number as well as finding the nth Fibonacci number by using recursion. Now, we are going to see in detail about the factorial of a given number using recursion. See here, I am going to write the statements like that. The factorial of a number n if n equals to 0 is 1. The first condition I am saying is if n equals to 0, the factorial is 1. If n is greater than 0, if n is greater than 0, then we are going to write it as n into fact of n minus 1. What is fact? I am going to use the user defined function fact, which is going to find out the factorial. So, these are the two important conditions to find out the factorial of a given number. Now, how the program will be executed, okay, using the recursion concept. So, let us see in detail. Here I have given the code, only the definition, the body of the factorial function. Generally, this factorial function will be executed from the main. Here I am writing the rough code. In the main, assume that we are going to call the function. What is the function we are going to call? Factorial, and we are passing the value n. Okay, and we are assuming that n value how much? 5. And we are printing the factorial here, right? Percentage d, and here some variable I am writing f. Okay, roughly I am writing, and f equals to fact of n, and here I am printing f. Just rough code I am writing. Now, as we all know that the execution starts from the main, right? In the main, we are calling the function factorial. Now, the control is jump to the factorial. Now, clearly I will explain how the tracing will be done. See, here I am going to take a stack. Carefully see this. I will explain what is mean by the stack. Stack is a data structure which uses the concept of last in, first out. In detail, we will see at the time of discussing data structures. Now, what I want to say is that the execution of the recursion uses the concept of the stack. Now, first, the execution starts from the main, right? When the execution of the main function is started, it is pushed onto the stack. Okay, so this I am writing main. Main function is pushed onto the stack. Now, what are the variables in the main? The variables here are one is n. Assume that the n value how much? 5. Okay. Now, in the main, we are calling the factorial function. In the main, we are calling the which function we are calling? Factorial. Now, we are entering into the next function is fact of n value how much we are passing? 5. Fact of 5. When we call factorial function, then again that factorial function is pushed onto the stack. Pushing means inserting, right? So here, this is the place reserved for the fact of 5, and this is the place reserved for the main, and this place is known as the activation record. Very important term, we call it as activation record. This is also activation record, right? So in the fact of 5, what is the value of n? N value here is 5. Now, see here in the main we are calling fact of n. Now we are jumping to fact, right? Fact of 5. N value how much? 5 here. Now assume that the first statement in the fact you number as 1 and second one is 2, else is 3, and this statement is 4, right? So we are executing this fact of 5, okay, n value is 5. So is n equals to 0? No, we are not executing the first statement. Are you first statement is false, right? So first we are comparing n equals to 0, right? Okay, now this condition is false, then the second statement, return 1 is not executed. See here, I'm keeping cross mark for the second statement. So first we are checking n equals 0, it is false, right? So that's why return 1 is not executed. Now we are going for the else part. This fourth statement is executed. In the fourth statement, please remember, while evaluating the parenthesis, first this n value how much? 5. Here I am writing here, just try to understand my writing here. 5 into fact of n minus 1, how much? 4. So instead of keeping this rightmost parenthesis, this is evaluated at the last. Now see here, n equals to 5. Now we are saying 5 into fact of 4. So you leave 5 here, but we are already in fact of 5. Again we are calling 4. You see this, we are calling fact of 4. Now we are jumping from this function called fact of 5 to next another function, that is fact of 4. Here I am writing fact of 4. Okay. Now this is the activation record for the fact of 4. Now we know that n equals how much here? 4. Again, now from here we are jumping to this, and here n value becomes 4. Now again condition is tested, is n equals 0? No. Again else part is executed. So here again what we are writing is 4 into, this is 4 into fact of 3. Okay. Now from here again we are jumping to another factorial. Okay. Now this is, we call it as fact of 3. Now in this case n becomes 3, and here we are writing 3 into fact of 2. From here again we are jumping to another function called, this is fact of 2. Now here n equals to 2, and the return value becomes 2 into fact of 1. From here again we are jumping to another function called fact of 1. Now here n value becomes how much? 1, and here we are going to say 1 into fact of 0. Now here there is no place, again we are entering into fact of 0. Here n value becomes 0. When n equals to 0, then what the value it is going to return? It is going to return 1. Okay. So when the first time n value becomes 0, then return 1 is executed. So return 1 meaning is we are returning the value 1 by terminating the function. So we are at which function? Fact of 0. This fact of 0, here no place, please try to understand. When n value becomes 0, we are returning 1 here, returning 1 back from here. While returning, we are bringing the value 1. And when you enter into fact of 1, this fact of 0 activation record is deleted. That means stop. Deletion is called. Now at this fact of 0, we got the value 1. Now here on return, what we are going to do is we are going to multiply 1 into 1. 1 into 1, how much? 1. So this one is, this result is, again we are returning back to statement. See here, so we have moved from which statement? Fourth statement, right? So we have to return back from all the function calls to return statement 4. So by using the return address, it is coming back. Now what I said, so fact of 1 means 1 into 1, how much? 1. 1 is returned back to here. Now how much fact of 1 now? 1. 2 into 1, how much? 2. 2 is replaced here. 2. 3 into 2, how much? 6. 6 is came back to this 6. Now say 4 into 6, how much? 24. This place we are going to get 24. 5 into 24, how much? So it is going to give the value 120. So 120 is given to the main. So this is the evaluation of the factorial program, right? So in one sentence, I can say that here, just whenever you call the function from the main like this, fact of 5, the execution will be taken. Fact of 5, it is divided into what I said, 5 into fact of 4, right? This is divided into 4 into fact of 3, and this is divided into 3 into fact of 2, and this is divided into 2 into fact of 1. This is divided into 1 into fact of 0. So what is the fact of 0? Return 1, 1. So Factor of 0 value is 1, and after that it is coming back, and this function is not there in the stack. So 1 is written back here. 1, how much? 1, 2 into 1, 2. Here we are getting 2. So next 3 into, we are getting 6. Here we are getting 24. Here we are getting how much? 120, and that is written to the main. In the main we are printing 120. So this is the logic of the recursion to find out the factorial of a given number. After this, we will see the Fibonacci number. Now we will see how to find nth Fibonacci number using recursion. So let us go to that. Now, actually we read it as Fibonacci, but it actually not Fibonacci. We have to read it as Fibonacci. Fibonacci. That is the correct pronunciation. This sequence is developed by a Italian or a mathematician who belongs to Italian. So the name of the scientist is Leonardo. Full name I am writing Leonardo Fibonacci. This is the full name. So he invented this sequence. So that's why this series is named as Fibonacci series. Right? Don't say Fibonacci. Better to say Fibonacci. Fibonacci. Right? So that we will see. Now, actually, the Fibonacci series is given as the equation f of n is equals to f of n minus 2 plus f of n minus 1. I'm going to use a user-defined function. The name of the user-defined function is fib. Then what you have to do is fib of n is given as fib of n minus 2 plus fib of n minus 1. Right? So we know the first two Fibonacci numbers are fib of 0 is 0, fib of 1 is 1. These are the known values, or we call it as the base conditions. Base conditions. Instead of writing base conditions, you can also say that if n value is 0 or n value is 1, then fib of n is, what is this? N. If it is n, if n value is greater than 1, then you have to say that it is fib of n minus 2 plus fib of n minus 1. This is the logic. If n equals to 0 or n equals to 1, so then if n equals to 0, the fib is 0. If n equals to 1, fib of first Fibonacci number is 1, like this. If n is greater than 1, then you have to use the principle. In this case, right. So fib of n minus 2 plus fib of n minus 1. Fib of n is given as fib of n minus 2 plus fib of n minus 1. N minus 2 plus n minus 1. Now, what is the code here? See, similar to the factorial number, here we have defined a user-defined function fib, and we know that the execution starts from the main, right? In the main, we are going to take a n value, right? And we are going to call the function like assume that printf. We are printing like this %d, but this is nothing but fib of n. We know this is the rough code. The execution starts from the main, and main is going to call the fib. If n equals to, assume that 5, what would be the output of this program? That we will trace. Now, the tracing is done like this. See here, before writing the stack representation, the execution starts from the main, okay? The main is going to call the function fib of. So, this main is calling fib, right? By passing the value 5. Now, control is passed to the user-defined function fib, and its value is 5. Fib 5. Now, it is going to check the condition. This is the first condition, first statement. This is second statement, third statement, and this is fourth statement. Check the condition n value how much? 5. Is 5 equals 0 or 5 equals to 1? No. The second statement is not executed. We are checking the first condition, and the second statement is executed. Now we are going for the else part. Here again the fourth statement is executed. So first go to the functions which are inside the return. First fib of n minus 2 plus fib of n minus 1. So first you take this fib of n minus 2. That means from this fib of 5, we are going for fib of n minus 2 means 5 minus 2. How much? Fib of 3. This is fib of 3. Now this fib, when you call fib of 3, the control is again goes back to fib. We are already in the fib function with n value 5. Next we are moving to again same function. It is going to call the same function by calling it as fib of 3. Okay, first we are talking about fib of 3. Next we go for the fib of n minus 1, right? Fib of 3. Now in this case we are going to take n value 3, fib of 3. Okay. Now after fib of 3, now we are going to check this condition n value 3 here n is not equals 0 and not equals to 1. Again this else part is executed. Now again we are saying fib of, first I am talking about fib of n minus 2. Next we will go for fib of n minus 1. So carefully you observe this. From fib of 5 we are going for fib of 3. From fib of 3 we are going for 3 minus 2. How much? 3 minus 2, we have fib of 1, right? So in this case, when you take fib of 1, n value becomes 1. Is n equals to 1 here? Yes, the condition is true. Then the second statement is executed. What is the value it is going to return? 1. So in place of fib of 1, we are going to get the 1. So now I will explain in detail with this example. You carefully see this. Now, first main. In the main, we are supplying the value 5. Now we are calling fib of 5. Now this fib of 5 is divided like this, fib of 5. Now what do you say? N minus 2, right? First n minus 2, fib of 3. Now again n minus 2, fib of 1. Okay. Now fib of 1, when n equals to 1, we are getting the value 1. 1 is returned here, right? We got 1. So return 1, there is return n statement, right? Return n means n value 1. So return 1 or return n in the sense, we are going to return from the fib1 function back to fib3. Okay. Now while returning, we are bringing 1 and this fib of 1 is deleted. The scope of fib of 1 is gone, or I can say from the stack, fib of 1 is deleted or popped. Now, okay. So while I trace the program as a code, I have executed only the first part, that is fib of n minus 2. So what about the another one, fib of n minus 1? That should be executed, right? So see, when you, after coming back to fib of 3, so go to right side. Now in this right side part, we have to call the function fib of n minus 1. What is that? Fib of 2. N minus 1 means fib of 2. Why? Because this is n value, right? Fib of 2. Now fib of 2 is called. So when n value 2, then what happened? The else part is executed. Again, this fib of 2 is divided into first fib of 2. First, I am going to take fib of 2 here. Now, first part is fib of n minus 2. That means we are going to get fib of 0, right? Fib of 0, how much? If n equals to 0, return 1. Sorry, return 0. Sorry. If n equals to 0 or 1, return n. So what is the value we are getting? 0. So we are coming back to fib of 2 by returning 0 here. Okay. Now this is left side part is fib of n minus 2. What about the right side part? After coming back, you have to go to right side part. That means second part, fib of n minus 1. Here you are going to get fib of n minus 1 means 2 minus 1. How much? 1. When we execute fib of 1, n value becomes 1. When n equals to 1, it returns 1. Why? Because n equals to 1 or n equals to 0, return n. So we are coming back again here. So while coming back, we are returning 1. So after returning, by returning 1, we are going to terminate this fib of 1. So by returning 0, this is also terminated. Now here from left side we got 0, right side we got 1. What is the operation we have performed? Plus, right? Now 0 plus 1, how much? 1. This is returned back here 1. Now left side 1 and right side 1. What is the operation here? Plus 1 plus 1, 2. 1 plus 1, how much? 2. So it is going to return back to fib of 5 value 2. See, while returning back, so all the functions are terminated, are popped from the stack. While you evaluated from fib of 5, when we move from top to bottom, all the function calls are inserted to the stack. For those corresponding functions, the activation records are created. While returning back, all the operations or the functions are terminated and the corresponding activation records are popped, I can say deleted. Okay. Now, we have discussed only the left part of fib of 5. Left part of fib of 5 means fib of n minus 2 only completed. Now, what about the right side part? The right side part, again, you have to evaluate the same thing. Now, this is fib of, what I said, n minus 1. N minus 1 means fib of 4. Then again, it is executed, right? When it is executed, again, it goes to the left part. Left part is nothing but fib of n minus 2. That is fib of 2. Now again it goes to left side, this is fib of 0, and you know fib of 0 is 0. Come back by bringing 0 here. Okay, now what is the value it is bringing? 0. Now what about the right side part? Fib of 1. What is the value of fib of 1? 1. You bring back to 1, 0, and perform the operation plus 0 plus 1, how much? 1. So fib of 2 total value is how much? 1. Now what about this fib of 4 right side part? You evaluate again, that is fib of 3. Now this fib of 3 again divided into two parts. Left part is fib of n minus 2, how much? 1. Fib of 1, 1. You return 1 here. Now what about right side part? Fib of 3 is given as fib of 2. Right, this fib of 2 is divided into again fib of 0. 0 is how much? 0. Here we are returning 1. Right side fib of 1 is how much? 1. 0 plus 1, how much? 1 here. What is the operation we are performing? Plus 1 plus 1, how much here? 2. Okay, here you press operation 1 plus 2, how much? 3. Okay, now already this is 3, right? So what is the value here? Left side value we got here 2. Left side part 2 we got here, right side part we got 3. Now this is plus operation 2 plus 3, how much? 5. Fib of 5 we are getting 5. Fib of 5 we are getting 5. The output we are going to get is fib of 5 is 5. How it is printed? Let us see. The Fibonacci number series is 0, 1, 1, 2, 3, 5. You see this. Now, when you give n value 5, it is giving 5. What is that meaning? So, this is 0th Fibonacci number. This is first Fibonacci number. This is second Fibonacci number. This is third Fibonacci number. This is fourth Fibonacci number. And this is fifth Fibonacci number. When you give n equals to 5, it is giving fifth Fibonacci number. The answer is 5. So this is the execution process of Fibonacci series. So every time all the function calls are pushed onto the stack, and while returning all the activation records or the functions are removed or terminated. Finally, the control comes back to the main, and main is going to print the nth Fibonacci number is 5. So this is the execution part of the Fibonacci series. Now we will see the programs using Visual Studio Code. Now we'll see the execution of the programs, Factorial as well as nth Fibonacci number. So let us go to the Visual Studio Code. Now go to new file. Now name it as fact, right, recursion.c. Now I'm writing this program to find the factorial, to find the factorial using recursion. Okay, now hash include stdio.h int main. Okay, now opening brace. Now the variables I'm going to declare is integer n. Okay, printf, you say enter any any number /n, right? Scanf percentage d double quotes close comma ampersand n, right? Semicolon. Now here, see, before this, after int and declare the way factorial function integer fact, this is function declaration, right? Now semicolon, before going to call the function, you will declare the function, right? Now after this, instead of taking any other variable and saying like f equals to factor of n, directly you can print the value, right? See here, printf, I'm writing like this, factorial is percentage d slash n. Instead of taking a separate parameter like f and saying f equals to factor of n, LHS and RHS, directly you can call the function in the printf. That is also valid, right? Here what I'm going to do is I'm going to call here fact by passing the value n here. So last statement is return 0. This is the main function. After the main function, next we are going to define the factorial function. So the factorial function is like this: integer fact integer n, right? Integer n. Now opening brace. Here just to write the code that we have discussed so far, right? Just I said that if n equals to 0, then I said return 1, else return, so wait, else return in bracket, I said that n into fact of n minus 1, right? So that's all. So this is the simple code. This is the definition of the function which we have already explained. So first we will see whether there are any errors. Now I'm going to run it to check the errors. Wait. See here, it is not giving any error. So directly it is printing that enter any number. Give n value as 5. Press enter. Factorial is, okay, it is not printing original value. It is printing factorial is percentage c. So some mistake is there. Now see here, what is that? Factorial is, here I have not written d, percentage d, right? Now save here, again run it. See here, it is asking enter any number and you give 5. What is the answer you got? Factorial is 120, right? Just fastly I will explain the code, the execution part of this. See here, the execution starts from the main. Here the execution starts from the main, right? This is variable declaration and this is function declaration, or we call it as function prototype. And it is, we are saying enter any number. Okay, it is printing the message and we have read n value how much? 5. Now you see printf. See carefully what it is going to print here is, first in the printf statement, carefully observe this. First we are going to print factorial is, okay, on the output. First it prints factorial is. After printing factorial is, it is waiting for the percentage d. What is percentage d? It is the value of this fact of n. What is this fact of n? Function calling. So it is not directly going to print the value here. It is the value of fact of n. Then what happens? It is going to call the function fact of n first, right? From this place, fact of n, the control is passed to this statement, function definition, and it goes to here. N value how much? 5. Is 5 equals to 0? No. The condition is false. Then this statement return 1 is not executed and this else part is executed. See, directly the return statement is not executed here. You go to parenthesis, n value how much? 5, right? 5 into fact of 4. 5 into fact of 4. First from the main we have called fact of 5. In the fact of 5 again we are calling fact of 4. Just already I explained in by using the stack, same thing is happening. From fact of 5 we are moving to again the same function here. Again we are checking the condition. this part is not executed. Why? Because n value how much? 4. Return 1 is not executed. Now here previously we have came from 5 into factor of 4. Now in place of factor of 4 we are going to get 4 into factor of 3. Same logic. It is repeated. Okay. So finally n value becomes 0 and here we're returning 1 and that is written back. Already we discussed this procedure. So finally it is going to return how much? 120. In place of percentage d, 120 is printed. So everything we have written, we have seen theoretically. This is only the execution code of the entire program, main as well as the function fact. Okay. Now after completing this, next we are going to see the Fibonacci number program. So go to the new file. Okay. Go to the new file and you write fib recursion.c. Okay. Now firstly I'm going to write program to find nth Fibonacci. Okay. Sorry. What is that? Fibonacci number using recursion, right? Okay. Now you know the statements hash include, okay, stdio.h. Next, int main opening brace. So we need some variable integer and declare the function integer. What the name of the function? Fib. We are going to take one argument, right? So it is like a function with return type and with arguments, right? Okay. Now after this, you say printf, enter any number, but right next to slash n double quotes close, next you say scanf percentage d, okay, double quotes close, comma ampersand n, right? Now you say in printf directly as we have done earlier, nth Fibonacci number is same percentage d slash n. So here right side I'm calling the function fib in bracket n, right? Last statement return 0. Okay. After this, go to the definition of the function. What is the function name? Int fib. Okay. You pass the value n. Now, okay, opening brace. Here I said if code already we have seen, if n equals to 0, or I said if n equals 0 or n is equals to 1, then I said return n, else return what else return what I said, fib of n minus 2 plus fib of n minus 1, right? We will check it whether there are any errors once you save it. Now, if you see here, this is the main block, okay, and this is the fib block. Theoretically, we have explained only the fib block or function definition. We will check whether there are any errors. Okay, compile it or run it. It is taking time. Okay. Okay, it is asking enter any number. Just we have given 5, right? What the number we are getting? Nth Fibonacci number is 5. We got correct answer. This is a program to print the nth Fibonacci number. Okay. So with this, we are going to close the session. In the next class, we will see the remaining concept. Thank you for watching.